Hello, first class Java developers. Welcome back to my channel. My name is Akash, and today we are going to dive deep into two important JVM interview questions that have probably caused more developers to break into cold sweats than debugging a null pointer exception in the production code. So, if you have ever been in an interview where someone asked you about some JVM internals and you responded with something like, "Yeah, well, it runs the some JVM Java code," so then this video is definitely for you. We are going to turn you from someone who just uses the JVM to actually someone who actually understands it. So the first question is, explain the JVM memory model and the different memory areas, or how does memory management work in Java? Now, I know that you must be thinking, oh great, another memory management question. But stick with me, because understanding this is like getting the keys to the kingdom of Java optimization. So the JVM memory is divided into several key areas, and each one has its specific purpose. So think of it like a well organized office building where everyone has their designated workspace. So the first thing is the heap memory. So this is the place where all your objects live. So it is like the main workspace of your office building. So the heap is further divided into generations because the JVM is smart enough to realize that most of the objects will die young. So just like most of my college projects. Now we have young generations also, which are included into the Eden space. So this is the place where new objects are born, and two survivor spaces are also there, S0 and S1. So it is like a nursery where new objects hang out until they prove their worth to keep around. Then we have old generation also. They are also called tenured spaces. So this is where the long-lived objects go to retire. So these are the objects that have already survived multiple garbage collection cycle. They are like the senior most employees of your application. So the next memory is stack memory. So each thread gets their own stack, and this is where method calls and local variables live. Think of this like each employee having their own desk where they keep their current work. When a method is called, a new frame is pushed into the stack, and when it returns, that frame is popped off. So this is very beautifully organized, just not like my actual desk. Next area is method area, also known as a meta space after 8 Java 8 plus. So this is where the class level information is stored. The class definition, the method definition, string constant pool, the static variables. So it is like the building's blueprint and the employee's handbook all rolled into one. The next location is the PC registers and the native method stacks. So these are for keeping track of what each thread is currently executing, and for the native method calls respectively. They are like building security cameras and the emergency exits. Important, but not something you think about it every day. So now I will explain the answer in a very professional way, how you should answer in an interview. So the JVM memory model consists of several distinct areas. The heap is area is divided into young generation with Eden and survivor spaces, and the old generation with long-lived objects. Each thread has its own stack for method calls and local variables. The method area stores class metadata and static data. Memory management happens through garbage collection, which automatically reclaims the memory from the objects that are no longer required. Primarily using generational collection algorithm that optimizes for the fact that most of objects have short lifespan. So this was most about the first question. Another very important question is, explain the class loading process in Java, and what are the different types of class loaders and how they work all together. So In Java, the class loading is like having a very particular librarian who's very strict about following the rules, about how which book can be accessed and when. The JVM does not load all classes at startup. That would be like trying to memorize where all the books are kept in the library even before you want to read it. So now let's talk about the class loading process. So this is where the class loading finds the bytecode, basically the dot class file of the projects, and bring it into the memory. It is like the librarian finding the book you requested and bringing it to the front desk. Now let's talk about linking. So there are three sub phases of linking. First one is verification. So verification is making sure that the bytecode is valid and it won't crash the JVM, like checking if the book isn't blank pages or written in crayons. Second part is preparation. So preparation is allocating the memory for static variables and setting them into the default values. The third one is resolution. So converting symbolic references into direct references, like updating all the footnotes to point to the actual page number. Now, the second part is initialization. Finally, static initializers and static blocks are executed. This is when your class truly comes to life. Now, let us understand the class loader hierarchy. There are different type of class loader. The first one is Bootstrap loader. So this is like the granddaddy of all the class loaders. This is basically written in the native code and it is responsible for loading all the core classes in Java, like object class, string, system. So this is like the head librarian who has access to most of the important books. Now, second type of class loader is extension class loader. This basically loads all the classes from the Java extension directories. So in Java, after Java 9, this becomes as a platform class loader. So think of it as a specialized librarian who handles technical manuals and some reference books. The third one is application loader. So this loads the class from your class path, basically your application code and your third party libraries that you are using. So this will be like your personal librarian who is helping you to find the book that you actually want to read. Now, another main concept in this is the parent delegation model. So this is where it gets very interesting. Now, when a class needs to be loaded, the class loader first asks its parent to load it. Only if the parent cannot find it, it load the class itself. Now, it is like asking your boss before making any decision. Sometimes it is annoying, but most of the time it's prevent the chaos. Now, another is this delegation model ensures that core Java classes are always loaded by their Bootstrap class loader, maintaining the security and preventing you from accidentally replacing some string with your own implementation, which would be very interesting. Now, now I will answer this in a very professional way, how you would answer this in an interview question. So, class loading in Java follows a three-phase process: loading, linking, and initialization. The JVM uses hierarchical delegation model with Bootstrap extension and application class loaders. When loading a class, each loader first delegates to its parent, only attempting to load the class itself if the parent cannot load it. So this ensures the core classes are loaded by trusted loaders and maintain the integrity of the Java runtime environment. So classes are loaded lazily basically when they are first reference. And if you have it, the two JVM. So these were the two JVM questions that makes the big difference from getting that Java developer position and having to explain why you are still looking for work. Remember, understanding the JVM isn't about answering the interview question correctly. So when you know how memory is managed, you can write more efficient code. When you understand the class loading process, you can better architect your application and troubleshoot the mysterious class not found error that might seem out to appear out of nowhere. So the key to nailing these interview is not just memorizing these concepts, but to understand the whys behind them. So the JVM was designed with specific performance and security goals in mind, and every feature of JVM serves a purpose. So if this video helped you understand JVM better, give it a thumbs up and subscribe for more Java interview content. So drop a comment if you have any other JVM topic that you would like me to cover, or share your own interview question and how was your JVM experience. Thank you.